What is happening? Something interesting happened next. Only one bulb of the chandelier has gone out, but for the decoration lights, all the bulbs have stopped working. But why? It's time to learn about grouping of lamps. An electric circuit is a path along which electric current flows. A simple circuit has a dry cell, bulb, and a switch connected by wires. But what happens when there are two bulbs? How can we connect them? One of you think that we can connect the second bulb right next to the first bulb, and the other one think that we can connect it above the first one. Let's now speak about the first connection when the lamps are connected one after the other. The lamps in this connection are connected in series where all the components form one loop. Then we can connect the second bulb here or here. It's the same, they are all connected in series. One of your friends gives a hypothesis telling that the current passing through the bulbs is the same as that of the dry cell. So let's go now to the lab and make an experiment to verify if this hypothesis is true or not. Let's now make the same electric circuit. This is the dry cell. This is the first lamp. This is the second lamp. This is the switch. And now we must connect them using the connecting wires. If I close this switch, then the lamps can glow. Okay. Now, in order to find the intensity of the current of this dry cell or of the main current, we have to use the ammeter that must be connected in series. I'll cut this wire and bring the ammeter. So the intensity of the current or that of the main current that is sent from the dry cell is 0.45 ampere. What about the intensity of the current of the first lamp and that of the second lamp? Okay, it's also 0.45 ampere for the first lamp. Also, it is 0.45 ampere. What can you conclude? The current that passes through the lamps grouped in series is the same as that of the dry cell. So I of the dry cell, that is the intensity of the main current in the circuit, is equal to I of lamp 1 and I of lamp 2. So your friend's hypothesis is true. What about the voltage of these lamps relative to the voltage of the dry cell? In order to find the voltage of these lamps and that of the dry cell, we have to use the voltmeter. So we have to connect this voltmeter in parallel across the first lamp to find the voltage. So the voltage of this lamp is 4.5 volt. For the second lamp, The voltage of the second lamp is 4.5 volt. What about the voltage of the dry cell? The voltage of the dry cell is 9 volt. Let's now replace one of these lamps by another kind of lamp. So the voltage of the first lamp is 0.82 volt. That of the second one is 8.18 volt. That of the dry cell is 9 volt. So, what can you conclude? What is the relation between the voltages of these lamps and that of the dry cell? Look at these values of voltages of the lamps and dry cell that are obtained in these two circuits, then try to find the relation between them. .5 volt plus 4.5 volt gives 9 volt, and 0.82 volt plus 8.18 volt gives 9 volt. So, the sum of the voltages of the lamps that are connected in series is equal to the voltage of the dry cell. You have to keep in mind that when many lamps are connected one next to the other across the terminals of a dry cell, these lamps are connected in series. And in this connection, there are two laws. The first law states that the current of the dry cell is equal to the current of the lamps, and the second law states that the voltage of the dry cell is equal to the sum of the voltages of these lamps.